Then 4.3, power. What is power? Power is defined as the rate at which work is done, or we can also describe it as the rate at which energy is transformed from one type to another type. So power is a scalar quantity. The SI unit of power is watt or joule per second. So for practical purpose, sometimes we are going to use a larger unit, which is horsepower, HP, whereby 1 HP is equal to 746 watts. So basically, in general, actually power will tell you how fast the work is being done or how fast the energy is being transferred. Because if you refer to the definition, it's the rate at which work is done. Rate means divide by time. So the power will tell you how fast you do work. Okay, how fast the energy is being transferred. So anyhow, we have to bear in mind the rate of which work is done might not be constant throughout the whole process where we perform the work. Okay, so basically we have two types of power. First one, we can calculate average power, P average. So average power is referred to the total work done during a time interval divided by the durations of time taken to do the work. Okay, since work done in a process might involve the transformations of energy, so we might also define average power as the rate at which energy is being transferred. So we might have the change of energy that occurs during that particular time divided by the time taken for the transformations of energy. Okay, the instantaneous power might be different from average power because the rate at which work is done might not be constant. So the instantaneous power actually is referred to the power at some moment or at a particular time. For example, instantaneous power at time 20 seconds, or the instantaneous power of the car when the car is moving at 10 meters per second, the instantaneous power of a lorry when the lorry is moving at 120 kilometers per hour. That one we call instantaneous power, the power at a particular time or particular velocity. Okay, so how we define instantaneous power? So P will be the limiting value of average power as the time interval delta t approach 0, or in easiest way, instantaneous power will be the time rate of doing work, dw over dt. So class, basically in mechanics, the instantaneous power can also express in terms of force and velocity. So we consider a constant force of magnitude F is acting on an object while the object is moved through a parallel displacement of magnitude S in the time interval of t. Okay, so we assume under the action of this force F, the object moved through a displacement of S in within time t. So the instantaneous power will be dw over dt. So class, as the object undergo displacement S under the actions of constant force F, actually the object is doing work. So we can calculate the amount of work done during the process by taking the component of forces that parallel to the displacement multiplied with the displacement. So we have F cos theta multiplied ds. So put it into the equations, then we know that ds over dt, the rate of change of displacement with time, actually is referred to velocity. So we can simplify the equation become P equal to F cos theta multiplied V. Rearrange, we are going to have P is FV cos theta. So the instantaneous power can calculate by taking the magnitude of the force multiplied with the magnitude of the velocity and multiplied with the angle between the vector force and also the vector velocity. So if we recall the scalar product that we discussed at the early of the topic, so we know that Fp cos theta actually is referred to dot product. So we can rewrite it as P equal to F dot V. So class, you can try to do tutorial for question 9 by referring to the concept of power we discussed in this video.